Welcome, economic students, to this video lecture. The purpose of this video is to explain the chapter on basic macroeconomic relationships, and most important, the idea of the GDP or Keynesian multiplier. John Maynard Keynes was the first one to identify definitively the relationship between disposable income and economic activity. So let's look at this basic macroeconomic relationship. After taxes, us human beings living here on planet Earth in the United States of America have two choices. We can either spend our money or we can save our money. So we start off with this simple idea that disposable income must equal consumption plus savings. With a little bit of algebraic magic, we can figure out that consumption therefore equals disposable income minus savings, and savings equals disposable income minus consumption. Let's visit the Keynesian view of the macroeconomic world. Within a country, Keynes identified an important relationship. If an individual or an economist is attempting to identify how much economic activity or calculate how much economic activity takes place within a nation, he figured it was a very simple relationship between the amount of income that was being generated within that country and how much of that income would be spent on goods and services. This Keynesian view of the world is referred to as economists now as the Keynesian cross. It is one model of the macroeconomic picture. However, it is not the model we're going to be using. Therefore, we will briefly discuss its merits and its shortfalls. In the Keynesian world, he drew a line, this 45-degree line, and on that line, it is every point where disposable income equals consumption. You can see consumption is graphed on the vertical axis, or measured on the vertical axis, I should say, disposable income on the horizontal axis. And for Keynes, it was simple. If you want to know the amount of economic activity, you simply look at what he called the consumption schedule. Therefore, if income were to increase, the consumption schedule would shift upwards on this 45-degree line, and economic output would increase. And if income decreased, the consumption schedule would shift downwards or to the left, and the amount of economic activity would decrease. The problem with this model is what economists refer to as a stagnant price model. Although it does a good job of explaining the relationship between disposable income and also how much economic activity will take place, we can sort of infer unemployment rate, but there's no way to talk about price level, so it's a stagnant price model. But Keynes did make some major contributions to economic thinking, which we're going to examine right now. So let's look at what is referred to as the average propensity to consume and average propensity to save as a starting point of the mind of John Maynard Keynes. If you think about an individual or a nation, we say, okay, if somebody makes $50,000 on average, how much of that money do they spend? Or if a country generates $10 trillion worth of income, how much of that money do they spend? Whatever portion of the money is not spent is therefore saved. So the average propensity to consume is simple enough to calculate. It's simply consumption over income. The average propensity to save is savings over income. Let's use these examples to explain exactly what we mean. As mentioned before, let's say a person makes $50,000, and let's say that they spend $45,000 and they save $5,000. Therefore, their average propensity to consume is 0.9, 45 over 50, or 90% of their income. And their average propensity to save is 0.1, 10%, 5,000 over 50,000. We can use the same logic to explain the nation as a whole. As mentioned earlier, let's say the country generates $10 trillion worth of income, and that Americans spend $9 trillion of the $10 trillion worth of income generated from the economic activity and save $1 trillion. Therefore, the average propensity to consume for the entire nation is 0.9. That is to say, on average, people spend 90% of their income. By default, people will therefore save 10% of their income. Now, notice the average propensity to consume plus the average propensity to save must add up to 1 or 100% of the income. Whatever income is not spent is saved. Whatever income is not saved is spent. Here's a little global perspective on average propensities to consume for various nations. Notice that Americans spend a large portion of their income, on average 96.3%. Canadians aren't too far behind. France, the people in France, they tend to save more. According to this graph, French people spend only about 83% of their income. Remember, economic thinking is marginal thinking. Therefore, what happens when income level changes? That is to say, if the individual we examined earlier in this video has an increase in disposable income from 50 to 55,000, or the country as a nation has an increase in income level from 10 to 11 trillion, how will that additional income be spent or saved? What portion of it will be spent? What percentage of it will be saved? That idea is referred to as the marginal propensity to consume and the marginal propensity to save. Again, these are easy enough to calculate. The marginal propensity to consume is the change in income, is the change in consumption, over the change in income. It is the percentage of the change in income that is spent. It is the percentage of the additional income that is spent. The marginal propensity to save, well, whatever additional income you did not spend, you therefore save. So it is the change in savings over the change in income. Notice these two formulas look quite similar to the average propensity to consume and average propensity to save. It's simply change in consumption over change in income, and change in savings over change in income. These examples should help clarify the point we were making on the previous slide. If a person makes an additional $5,000, that person will say spent 4 of the 5,000, so their marginal propensity to consume is 4,000 over 5,000, or 0.8, 80% of their income. So the marginal propensity to consume for that individual is 0.8. By default, whatever they didn't spend of the additional income, they must save. So their marginal propensity to save is 0.2, 1,000 over the 5,000. Notice again that 0.2 and 0.8 add up to 1. What about the nation as a whole? Let's say that the nation as a whole generated an additional $1 trillion worth of income, and Americans spent $800 billion out of the trillion and saved $200 billion out of the trillion. Well, the numbers work out to be the same. The marginal propensity to consume for Americans is 0.8 or 80%, and the marginal propensity to save is 0.2 or 20%. And again, the marginal propensity to consume plus the marginal propensity to save must add up to 1. Now, this point is extremely important. The reason why economists like the marginal propensity to consume or the marginal propensity to save is that these two figures, these two ideas, these two concepts can be used to help calculate what is called the multiplier. So if you see this last point down here, it says the MPC, marginal propensity to consume, or the marginal propensity to save can be used to calculate the value of the multiplier. Before we look at these formulas on how to calculate the multiplier, let's just discuss what economists mean by the multiplier. It is easier for students to understand or grasp this concept if we talk in generalities. In other words, let's say that I walked into a store just before close of this store and I spent $1,000 on a new coat. The income of that store went up by $1,000. Therefore, GDP increased by $1,000. Economists are interested in calculating if income and GDP, because remember there's two ways to measure GDP. We can either add up the money that is spent on final goods and services, the expenditures approach, or the income generated from that very same activity. So the code example, if I walked into this store, that is $1,000 worth of expenditures from my standpoint. From the store's standpoint, it is $1,000 in additional income. But the question is, how much does the initial change in spending or income ultimately impact the entire economy, ultimately move or change GDP? So if I spend $1,000 and then the owner of the coat store takes the $1,000 and spends 80% of that. Well, we know that 80% of 1,000 is 800. So that store owner walks down the street and spends $800 on new furniture for his living room. You can already see that the economic activity associated with the initial change in spending is greater than 1,000. I spent 1,000. The owner of the coat store spent 800, so GDP has increased by 1,800. And then let's assume that the furniture store owner took the 800 and spent $640, or 80% of that, and say bought his wife some nice piece of jewelry for their anniversary that worked out to be exactly $640. Economists refer to this idea of an initial change in spending having a much larger change in economic activity as the multiplier effect. So, what is the value, or how do we calculate how large the multiplier effect is? As mentioned earlier on the previous slide, we can use the marginal propensity to consume or the marginal propensity to save to calculate the value of the multiplier. Theoretically, if we know the marginal propensity to consume, the value of that idea, or the value of the marginal propensity to save, we can calculate the value of the multiplier. So this formula tells us that the multiplier equals 1 over 1 minus the marginal propensity to consume, or 1 over the marginal propensity to save. Either one of these formulas can be used to calculate the value of the multiplier. Let's demonstrate mathematically how an initial change in spending creates a much larger change in GDP, in economic activity. Let's assume that investment spending increases by $5 billion. So a company spends $5 billion refurbishing a large factory. There's the initial change in spending. Let's assume that the company who receives the contract will ultimately spend 75% of the $5 billion. That works out to be $3.75 billion. So GDP first increased by $5 billion, and then the second round of spending increased economic activity by another $3.75 billion. And then, of course, the third round, let's assume that another company spent 75% of the 3.75, and now you can see that the initial change in investment spending to refurbish the factory has ultimately created a larger impact on economic activity. We could keep going through these rounds and calculate the complete or ultimate effect on economic activity by doing the same exercise over and over. Now, this is very cumbersome when you talk about the math, but look for a moment at the marginal propensity to consume and marginal propensity to save in column 2 and column 3. In this example, we assume that the marginal propensity to consume is 0.75 and the marginal propensity to save is therefore 0.25. Using the formulas from the previous slide, we can calculate the value of the multiplier. The multiplier can be calculated by taking 1 over 1 minus the marginal propensity to consume. So in this case, 1 over 1 minus 0.75, which works out to be 4, or 1 over the marginal propensity to save will also give us the value of the multiplier. So 1 over 0.25, which obviously also equals 4. So the multiplier in this economy is assumed to be 4. If the initial increase in investment spending was $5 billion, 5 billion is the initial change in spending times the multiplier 4 makes it easier, much easier to calculate the total effect on GDP. That is the power of the multiplier as an economic tool. If the multiplier can be calculated using the marginal propensity to consume or the marginal propensity to save, it is easy to quickly calculate how an initial change in spending will ultimately impact GDP. We've only been talking about increases in spending. The Keynesian world was a much different picture. Keynes was writing during the height of the Great Depression. He was using this concept of the multiplier to explain how decreases in spending were ultimately creating much larger decreases in economic activity, in GDP. So the multiplier works in either direction. If this company had cut investment spending by 5 billion, so assume that ABC factory was planning on expanding their plant, and all of a sudden they cut $5 billion worth of investment spending. Then the math would be the same, except that $5 billion would be a negative number to start. Negative 5 times 4 would ultimately create a decrease in GDP of $20 billion. Let's see how we're doing with this concept of the multiplier. The formula up top is important to understand. If we want to calculate the total change in GDP, we take the value of the multiplier times the initial change in spending. So take a moment and look at this problem. How much will a $20 billion increase in investment spending ultimately affect GDP if the marginal propensity to consume is 0.6? So let's see how you did. Let's tackle the problem. The total change in GDP equals the multiplier times the initial change in spending. The problem gives us the initial change in spending. A company has increased investment spending on some machines or equipment or some large factory, some plant by $20 billion. That's the initial increase in spending. What is the multiplier? The problem gives us the size of the marginal propensity to consume. We can use the marginal propensity to consume to calculate the value of the multiplier. The formula tells us that the multiplier equals 1 over 1 minus the marginal propensity to consume. So 1 over 1 minus 0.9, because it tells us the marginal propensity to consume in this economy was 90% or 0.9, equals 10. So 1 over 1 minus 0.9 equals 1 over 0.1. 1 divided by 0.1 equals 10. So if we take the 10, the size of the multiplier, times the $20 billion increase in investment spending which started the economic activity, ultimately the multiplier tells us that there should be an increase in GDP of $200 billion when it is all said and done. This will be the final slide on this particular video, but it is a useful slide for two reasons. Number one, students who hate math can use this slide to easily calculate the size of the multiplier given various marginal propensities to consume. So it shows us that if the marginal propensity to consume is any of these values, then the multiplier can be calculated easily using this without even actually doing the math. I don't think anyone will have any trouble doing the math. The formula is not that difficult. The nice thing is, if you know the marginal propensity to save, you can also use this cheat sheet, because if the marginal propensity to save in a given economy is 0.2, by default, 1 minus 0.2, the marginal propensity to consume has to be 0.8, right? More importantly, this slide demonstrates an important economic idea. The larger the marginal propensity to consume, the greater the size of the multiplier, which should make sense. What we're saying is that if on average people decide to spend a larger percentage of their change in income, the ultimate effect or the multiplied effect on GDP will be larger than if the marginal propensity to consume was a bit smaller. I hope you've enjoyed this presentation. Look forward to interacting with you on other videos.